Alrighty then, where did we leave off? Oh yeah!
Target the Weavers. Target everyone! Somebody fire!
I'm a leaf on the wind. Watch how I soar.
All this luxurious eye candy. As much as we have enjoyed it, I must admit now that I have made a ghastly omission, and it is of glaring importance. You see, until we do address it, absolutely none of this eye candy is ever going to occur. Want to know what that problem is? Speed. Right now, our fastest ship is so slow it'll take 40,000 years even to reach the next star, let alone reach any alien empire to start a space war with. We're stuck here. One solar system, one planet, until we make that quantum leap in space travel faster than light. This isn't just a sci-fi luxury. This is essential. Without it, none of this is going to happen. We're not going anywhere. We've got to get on it. The first obvious problem is, of course, space is just too gosh darn big. It's so big that it's absolutely worthless to try to measure it in anything as measly as a mere mile. Not that you'd ever know this by watching television, which shows starships just zipping around from planet to planet just for light afternoon entertainment, totally ignorant of the vast distances involved. Space is so big it gets its own units of measurement, and I bet you haven't heard of all of them. The measurement you've heard most often needs no introduction: the light year.
Unless something's wrong with our sensors, sir. We're almost 30,000 light years from where we were.
Light years are used so often because they're hysterically easy to explain. Merely the distance light travels in one full year, almost 5 trillion miles.
According to these coordinates, we have traveled 7,000 light years and are located near the system J25.
But 6 trillion miles is little much. For distances a little closer to home, there's another measurement I bet you haven't heard of: the astronomical unit.
Ixion, a territory of monumental strategic importance, being a mere 50 astronomical units from the Chig's home planet.
The astronomical unit is meant to measure distances from planet to planet, and that's exactly how it's defined. The distance from the planet Earth to our sun, 93 million miles. Its small, bite-sized nature makes it perfect for mapping out the distances inside your own solar system. For example, if the Earth is 1 astronomical unit away, then Mars is 1.5. Farther away, Jupiter is 5, Saturn is 9.5, and woebegone, recently demoted planet Pluto is 39.3 astronomical units away. Now, despite its convenience, you don't hear the word astronomical unit very often in sci-fi. In fact, since it can be easily abbreviated AU, you may have heard it without even knowing that you did.
Some kind measures over 2 AUs in diameter. Must be something incredible inside there generating it.
But if sci-fi does want to get your attention, there is one more space measurement which it can't resist using as often as possible.
Break off pursuit and return to base. He could be 1 million parsecs away by now, and probably is.
Whenever you're in a hurry, in trouble, or want to impress somebody, you use the word parsec.
Doctor, that asteroid is a parsec behind us and has a Cylon Sentinel post. We can't go back.
I mean, a parsec is the most complicated thing you've ever heard of in your whole life. I'll try to explain it best I can, but the best way to get through this is sit down and hold on. On our planet Earth, on a clear night, we can see thousands of stars just with our naked eye. In order to catalog and map them correctly, astronomers have divided our night sky into 360 slices called degrees. Each degree is divided up into 60 more slices called arc minutes. And every arc minute is divided up into 60 more slices called arc seconds. This means there are 1,296,000 separate slices of night sky, when you absolutely, positively have got to map a star to within an inch of its life. Keeping up? Good, because now it gets really wacko. Suppose you're an astronomer on our planet, and our planet is right where it's supposed to be in orbit around our sun, with its radius of 1 astronomical unit and total orbit diameter of 2 astronomical units. Woohoo! Now, as the astronomer, you have a telescope that sees exactly 1 arc-second slice of the sky, and when you point it up and look, you see across space another parallel planet exactly the same size as ours. Radius of 1 AU, diameter of 2 AU, and it's exactly the right size to fit exactly within your arc-second slice. This exact congruent convergence between solar systems, with astronomical units on one side, arc-seconds on the other, can only occur at a precise distance in space and time. This precise distance is called a parallax arc-second. Parsec. 3.26 light years. Which, in terms of the cosmic universe, really isn't all that much. Just a whole lot of trouble just to get to what amounts to a cosmic yard. But now you know, and at least it sounds cool.
All of a sudden, we're clear across the galaxy. 500 parsecs from where we are. Don't try and figure it out, Mr. Sulu.
And it's a start. We now have enough tools to keep going, to learn even more. So how deep in this rabbit hole do you want to go? Follow me. There's more.